Hi YouTubers, Benjamin here. Hey, how are you? Hey, I'm going to show you a project that I built. I found the plans from the internet. Imagine that. Just because I'm stupid and I don't know anything. Anyway, the project I'm going to show you it's obviously in developing stages, as you'll see here in a minute. But it's called it's a solar panel tracker for the sun. Yeah. Anyways, the long name is Solar Panel Sun Tracking Controller. I probably put that backwards because it's actually a sun tracking solar panel controller. So what it does, it tracks the sun, and then it moves the solar panel either to the east or to the west. To the west in the throughout the day, and obviously in the morning it'll reach it'll go back to the east to reset. But this is the basics of it. It's on a Heathkit breadboard. The brand doesn't matter. But you see my glob of wires here. What I'm using for sensors is LEDs. I just learned last week that LEDs produce a voltage when they're under a direct light. I did not know that, but since I have cheap sensors. And these LEDs, this one is for the east, I think. It doesn't matter. I'll figure it out. And one of these is for the west direction. So these will be put on the side on the left and right side of the solar panel. Anyway, when the LEDs see different shades of light, it's got a LM339 or KA339 or something. Anyways, it's got a quad comparator or operational amp in it, and it'll send a different voltage to the MOSFETs. I have two of each of the P-channel MOSFET and two of each of the N-channel MOSFET, and then there's a heavy-duty diode. And all these parts were stolen from power supplies and uninterruptible power supplies or UPSs. So if you say you ain't got the parts and you're broke, just go find someone with an old computer power supply and broken ups, most likely with a dead battery, and you'll have all your parts you need, minus the LEDs, which you can find those off anything. Like I said, these are from a VCR. Anyway, I just got it connected to a battery there and give you a glimpse of the schematic. This will be available on my blog in two forms, both as a PDF version, and also I did an Express PCB schematic, and I'm about to get it over to the Express PCB breadboard, so that way I can commit the project now that I figured out what I want. And then what I'm going to do is, before that actually, is I'm going to integrate these two LEDs so that way they'll light up for the east and west directions to give me an indication that the motor should be moving. So that way if the east or the west LED is lit up and the motor's not moving, there's a problem. Or if both of them are lit up, which that's not going to happen, then I got a serious problem. But anyway, here's the linear actuator from an old C-band satellite dish. This was from a 6-foot one. I'm going to put on a polar mount that I'm eventually going to find. And then here is my test light, flashlight. So I'm just going to, all I got to do to test it is just sign it. You may even hear it, but I'll show you here. I'm going to shine this on one of them. Let's see if we can do this one-handed. Come on, focus. Focus, you crazy thing. Oh well. You'll see it. So I'm shining on one, and you see it retracting. And I'm going to shine on the other one, and you should see it going out. Yeah, not very fast, but good enough. It does the job. And it's not going to move very fast because I think this actuator is 36 volts. So anyway, leave comments if you want. I'll post my personal blog page on there that shows you how to do it. I should learn to edit, so this isn't all on there, but oh well. I do things unscripted. But anyways, you'll check my blog that I have on there. I'll have that listed out. Like I said, I also have the PDF version of the schematic, so you can print it out and do it on your own breadboard, as well as the Express PCB schematic, as well, and the actual circuit layout, so that way you can make your own boards. And if you make any cool modifications to it, I'd like to know. Please post them. Thanks.